So first of all, once again, and thanks to Anup sir and Radish sir for giving me this opportunity to present about IoT in your in front of different students, like young innovators. So, our topic is IoT. So first of all, before coming into the any session, you should think what is that topic and why we are there actually, or why we need to attend that particular thing. So that is I am going to explain now. So what is IoT? Why should we care? Or what is the importance in IoT in at present world? So that's a question actually we should answer first. Then only we'll get the proper thing in that particular webinar. So first I am going to explain why we should hear. Okay. So this is our daily routine. You know that. So this is our daily routine. We will wake up. After that, we'll take a coffee. After that, we'll go for a jogging, and then we'll take a breakfast. After that, we'll go for office or school. Then evening we'll go for a play or something. So why I showed this is IoT is having its own presence in each and every aspect. So like it is going to bang in on every daily routine of our life. It is started. So I'll show that how it is affecting each and every point of our daily routine. So here you can see that. So nowadays, not in India, all other part of country, most of them are continuously wearing the smartwatches. So what's the need actually? What's the need of smartwatch in that? So that's a big question. So we know that smartwatch is having a lot of advantages, especially it is having a healthcare related application. It is inbuilt on that. So healthcare related application in the sense like with the help of smartwatch, we can able to monitor each and every part of our body routines. So why we know that most of the heart attack or heart failure is happening while sleeping. Correct. So nowadays, other part of country, the most of them are continuously wearing smartwatch. It will help actually continuously monitoring every time, each and every time it is monitoring the heart rate. If suppose something is gone failure, so automatically it will provide a message or alarm to the other persons. So automatically is very easily to detect and identify, and he can take him to the hospital. So automatically we can survive a life. So that's a one part. So that's a one part of a IoT. After that, this next picture you can see that there is a coffee machine. Small picture actually it's showed. So what's the importance in that? So there is a one coffee machine actually it is available. Like so first we will walk up. After that we will go for a coffee, right? So there is a one facility now it is available. At the walk up time itself we can send a message to the coffee machine. So at that time, automatically the coffee machine, whenever it is getting a message from the person, automatically the coffee machine starts making our own taste coffee. So after the preparation, automatically it will send back a reply to the corresponding person. So we need not to wait. So there is a relation. See, device to device relation it is showing. So there also it is an IoT. We need not to spend a time. So wake up time itself we will get a coffee. So like an alarm, we can set a timer also, we can set it. So automatically with the timer, automatically coffee machine start making the coffee. So that much advanced in IoT. So when we are coming for the next picture, so when we are going for a jogging or exercise, automatically always most of the countries, or I think in India also, most of them are wearing this smartwatch. So again, it is a health app. So it automatically, it will check the blood pressure, every part of the pressure, heart rate, everything it will check it. It will report as a message. So after that, the third picture you can see the bread toaster is there. So what is the importance of that? When after the jogging, automatically we will come to the breakfast session. So at that time we need not to wait for a breakfast. But while jogging itself, we can send a message to the bread toaster. So bread toaster automatically, whenever it is getting a message, bread toaster automatically will start preparing a bread toast. So automatically while coming back, automatically that breakfast it will be ready. So that again, so our food section, like our the breakfast session also, so IoT is playing a major role. So after that, when we are going for a office or a school, again each and every part of a device, electronic device, we can able to control with a one smart panel or with the help of mobile app, because each and AC, light, fan, everything we can able to connect with the IoT. So with the help of once we need not to go there and switch on the lights and everything. We can easily, we can sit in one position and we can able to operate all the devices with the help of mobile app. Again, there is a IoT part. So when we are coming into the last picture, you can see that the Alikumbla is sitting with a bat. So what actually it is, again IoT is having a major role in the gaming section also. Here actually what actually it is showing, that picture is it is a Anil Kumble. He's founded a one new IoT AI company. Its name is Spectacom, and they are producing actually a power bat sticker. So what's the use the power bat sticker? So that's the question. So it is a smart sticker. The for cricket bats, it can able to sense each and every shot of a batsman. I can able to store that result automatically. This will send a data to the mobile app and everything. So automatically one batsman, it can able to analyze his performance, day by day performance. It can able to analyze on where is the fault is coming. Everything it can able to monitor it, and the batsman can able to recover from that. So what's important in that is the bat is the normal bat. In that actually one sticker actually it is attached. That is actually a smart one. It's a sensor technology. Its name is power bat sticker. Okay, what actually it is doing is it captures key batting parameters as the action happens in a real time. And this sticker is a wireless charging, and it can connect it with the mobile app. So these are the features it is having. So these are produced developed by this Spectacom company. So that is the Spectacom company I found by Anil Kumble. So and at the same time they are having a partnership with Microsoft also, because they are using Microsoft IoT cloud actually they are using. So from now itself we realized that each and every part of our life IoT is playing, correct? So that is the importance of IoT at present world. So you know that, so first while sleeping there's IoT is playing, while preparing your coffee or breakfast, there also IoT is having a major role. Jogging, playing at the office, everywhere IoT is playing a major role. In 2030, in normal, what actually the survey is telling, 2030, most of our device is going to be converted into a smarter one. Smarter one in the sense like it can able to operate anywhere from the world. So that is the help of IoT only is possible. So that is the importance of IoT at present world. So this is my plan of presentation. So first of all, just briefly describe about what is IoT and from where actually it is, IoT from where it came from, and how IoT works, and some of the few applications of IoT, and what's the current status and future prospect of IoT, and technology challenge. Every technology will be having some challenges and problems, and some controversies also will be there. So that we will discuss. After that, but suppose we are coming into a real project, how IoT, how we can develop IoT, what are the controllers we need to select, how to communicate. For communicating, what are the devices actually we need, what are the different types of communicating devices, and what is mean by IoT cloud. So all these things we should know. So how we can able to connect a one device, suppose one bulb I want to connect it with a cloud, how we can able to. So all these things I will discuss in the last session. Okay. If you have any doubt or questions, you can put it in the chat box. So at the end of session, I will answer. Okay. So in simple words, IoT. IoT in the name itself, it is mentioned. IoT, the full form is Internet of Things. So IoT is having a major role in today's world because Internet is, now we know that Internet now it is common everywhere. Correct. In 5 years back, actually Internet it was not common. But now Internet is common everywhere, every rural places. Like, so same way, IoT also is going to be a bang on our every part of our life, and most probably 2030, like Internet of Things is going to be changed every part of our world. So what is mean by IoT? IoT means nothing but like, suppose we have a one bulb I have, and one mobile I have. Suppose I want to operate this bulb with this mobile. It is possible with the help of IoT. How? That's a question. So what actually we are doing is, at the one side we have a bulb is there, another side we have a mobile phone is there. So both should have a internet connection. With the help of this internet connection, this bulb and mobile we are connecting in a common platform. That common platform we can call it as cloud. Cloud is nothing but like a server only. So the bulb status, suppose if it is on, that on status it will share on the cloud. Same way, the mobile phone will be having a switches related to the bulb. So automatically that switch status automatically it will share it. So if it is when we are pressing on in the mobile phone, automatically that on, automatically the value will be always, it will be a 1. That one value automatically it will share into the cloud. That will come into the bulb, automatically bulb will turn on. If it is 0 or off, automatically that will reach at the bulb side. So automatically bulb will be off. So this is nothing but IoT. So IoT in the sense like two physical objects can easily accessible through internet. See, bulb we are connecting through a mobile phone with the help of internet. So that is nothing but is an IoT. So it is having a different names is there. IoT itself, it is having a different name. Machine to machine, machine to machine. See, mobile phone to bulb, or a smartwatch to coffee maker machine. So both are machines, right? So it can able to transfer a data from one machine to another machine, or it can talk each other. So that's why the name machine to machine. Skynet or internet of everything. So why it is the name came is, if we have it, if we need to develop a IoT system, so both the objects should be connected with the internet. Both sides should have an internet. Then only it's possible to control. So that's why internet of everything. Correct. So that is a thing about the internet of things. So internet of things is nothing but connecting a two physical object through a internet. Next, history of IoT, from where IoT came. Actually, the IoT, the name, it's a father of IoT, we can call it as Kevin Ashton. Kevin Ashton is the father of IoT, and he is actually a British technology pioneer who co-founded Auto ID Center at the MIT. Okay, so in 1999, actually he started a Auto ID Center to develop a RFID technology globally. So he has given one global naming for the RFID at the MIT Auto ID Center. So from there, actually, it is the IoT starts. So most of you know that what is RFID. So it's a radio frequency identification technology. So in the toll gate, or when we are going for a shopping, everywhere you can see that this RFID technology. The same thing only he has started in 1999. So RFID was the technology, is the base technology of a IoT. So from there, actually, it is started. So Kevin Ashton, he is the person actually who started the RFID. So that is the invention base point of a IoT, Internet of Things. So various names, various concept already it is having, because machine to machine, it's a name of it's another name of IoT. Internet of everything, that is Cisco Systems Private Limited. So they are actually named IoT as a Internet of everything. World size web. So Bruce Schneier, he's actually a American cryptographer, and he's a professor at Harvard Law University. So he has named the word world size web because it is going to change the world. So that's why everything it is going to connect with the web. So that's why he named world size web. So next, so now we know that what is IoT. IoT means in the sense like we are connecting a two physical object with the internet. Correct. So now how IoT works? So that's a question. So you can see this picture. So this is every part of IoT. It's it should require some different part. IoT is not like a mobile phone. Is not like a mobile phone one simple system. It is a coordination of different part or different systems. So that is then that is actually an IoT. So here you can see that IoT devices. First part you can, the right side bottom you can see that there's a car, bulb, washing machine, speaker. So different components are listed here. So that is actually, it is written IoT devices. So why it is IoT devices it is mentioned? We know that in our home or everywhere, in automobile sector, in home applications, or in all healthcare section, all application, if we have a electronic system, each system will be having a sensor, always will be there, correct? So with the help of this sensor, what actually this sensor is doing is the physical parameters is converting into electrical parameters. So we know that nowadays in automobile sector, IoT is doing a very large job in the automobile section. So like MG car, you can see that they came with the connected cars, correct? Like it is like a human being. They are telling the car is like a human. Car is a human nature. Like however we are speaking with the two human being each other, same way we can talk with the car also. Suppose if I am telling start the car, automatically car will start. Or switch on the light will switch on. Switch on AC. So it is like a normal human being conversation type. So that is the help of IoT only. IoT and other tech like a machine learning, AI also is there. IoT also it's having a major role in that. So in this IoT devices, the first important thing is all the devices should have a sensor. Then only this sensor only can able to convert a physical parameter to electrical parameter. With this, actually the data collected by the devices and that will be transferred. Always that devices here, the devices showing car, washing machine, bulb. Always these devices will be having a controller section also will be there. So automatically sensor whatever it is sensing, that data it will go to the controller section of a washing machine, and that will pre-process or process that data, and that data has to be transferred to the internet. To transfer to the internet, we should have an internet connection. So that way there we have used a router or gateway. So with the help of this router or gateway, whatever the data which is collected from the devices, it will be transferred to the internet network, global side. So internet network. So at the other side, there is a two things you can see that internet. So there is a red mark you have. So this is a data storage. So that is actually a cloud part. It is a common platform. So there actually whatever the data which is sensed by the device, that will be collected, and with the help of internet, it will be stored in the cloud spaces or data storage spaces. Okay, and another part you can see the remote control. Like there it is showing picture like a laptop, tab, mobile phones, correct? So suppose I want to see the temperature condition of a car. So how it will be? So temperature sensor always will be there. That temperature sensor will sense the temperature. It will go to the controller. The controller will be presided inside the car itself. So from that automatically it will connect to the internet. So through the internet it will store in the cloud. And the other part, suppose car is outside, I am sitting inside my room, I want to see the temperature. So through the mobile phone, always the application software always will be there. That will be common. Nowadays it is common everywhere. Through the application software, through this mobile app, it is connecting to the cloud like a data storage. So automatically the mobile phone will take a data from the cloud and we can able to see the temperature. With that actually again we can tell the mobile app to switch on the AC. So automatically whatever the command we are giving through the mobile phone, again it will go to the cloud store. So from the cloud store automatically it will come to the car will switch on the AC for a 2 minutes or 3 minutes. Like if timer facility is there, means automatically we can set the timer and can switch on the AC of a car for 1 hour or 2 hours, depend upon our requirement. So that is simply IoT works. So IoT, how it is work means sensor will sense the data. That data will go to the internet. Through the internet, it will store in the cloud. And another part, there may be another device, mobile app or actuator or something will be there. So actuator source mobile app, it will take the data from the cloud, or cloud will share the data to the mobile phone or mobile app. automatically we can see the status of that particular command, and with that we can take an action also. So that is simply IoT works. So now this is the IoT life cycle. So I explained there's a different part is there in IoT, like a sensor part is there. After that we have to connect the data to the internet, so there should be a communication part should be there. After that we should have to analyze the data, is the data is correct or no, or is the noise. So for that cloud it is having an analyzing section. After that there is an acting section. Acting section actually it come at the destination part. So that is mobile app or laptop, or there may be an actuator or anything. So these are the different life cycle operations: collect, communicate, analyze the data, then act. Depend upon the command we have to act it. So what is that collect? The collection part actually it's telling devices and sensors are collecting data everywhere, like your home, like your car, like your office, or in the manufacturing plant. It is sensing the data. Just now I explained it is transferring to the through the internet to the cloud. So cloud, what actually it is doing? It is doing the analysis part. After that, communication. So communication is the major role in the IoT section. We know that we know that the internet is one of the major role in that, and the communication part also is major role, because properly it has to, whatever the data is collecting, properly it has to communicate to the cloud. Then only the proper data it will be stored at the cloud place. Then only the correct data it will reach at the destination also. So communication is having a proper part in that. So here we have different communication technologies are there that I will explain later. Here internet, actually with the help of internet actually we are communicating all this. So internet, we are using a common internet, but at the same time there should be a communication controller also should be there. With that only we can able to connect with the internet or to the cloud. So that I will explain later. After that, analyze. So we know that we are storing the data, whatever the data which is collecting from the sensor, it will go through the internet and it will store the cloud. So in the cloud place, we have a facility like we can visualize the data, we can build a report, we can filter or we can remove some unwanted data. At the same time, we can predict the data also. So nowadays, the cloud part, the machine learning AI part also it is working. In that case, we can able to generate we can predict the data, and future data also we can able to predict it. So that part can be worked at the cloud portions. So after that, action I just I showed that at the end of the source is from the car and then is at the mobile phone. So mobile phone is the action part, right? I'm sensing the temperature, going to the internet, going to the cloud. So automatically from the mobile phone, automatically that also mobile phone also it is connecting with the cloud. So it is taking a data from the cloud. So it will get a notification. Suppose I want to from this temperature I want to do some action. So actuators can be able to work. So all this action can be possible with the action part. So these are the four section: collect. With the help of sensor, we will collect the data. After that, we will communicate through the internet. We will analyze at the cloud. After that, we'll act. It's a normal. Suppose we want to do a one project in IoT. So this is a normal block diagram, simple block diagram. So simple block diagram in the sense we can see that on the left side there is so many physical parameters is there. This physical parameter, this normally whatever the system we are using, that system actually its aim of that system is control some physical parameter. Like I want to control a temperature, or with the help with respect to temperature I want to switch on or switch off the fan or switch on the AC. With respect to the light, light condition I want to switch on or switch off the bulb. I want to check the pressure. So all this, so all the physical parameters we want to. So for that actually we are using a sensors. After that it is going for a gateway, then it is going to the cloud server, then at the final end it is a mobile app. So it's a two-way. In two-way also it can able to communicate. So one by one we are going to see. So in our simple mobile itself, it is having a lot of sensors are there. I think you know that this is showing a Galaxy S4. It is very old one. that itself, it is having a different sensor. You can see the picture. From the picture we can identify that so many sensors actually it is attached. So with the first one, air gesture, the top you can say green gesture sensor is there. With that you can able to recognize user hand movement using a infrared rays. So after that, it's a proximity sensor is there. It can able to recognize the mobile phone whether it is located near the user or not. So gyro sensor, so detect the mobile phone rotations. So after the accelerometer detects the mobile phone movement. After geomagnetic sensor detects the magnetic field intensity. So temperature sensor, it checks the temperature and humidity level. And barometer, it will check the atmospheric pressure. And hall sensor is there. You know that when we are opening and closing your mobile phone pouch, automatically it will sense. We know that we are normally using that one. And RGB light sensor is changing the light intensity and everything. So this type of different sensors are there. So every part of a electronic system is now equipped with a lot of sensors. So with this sensor, you can easily measure the physical parameters. So these all are physical parameters, right? So but physical parameter directly, if you are taking, we cannot able to do anything, any process. So that should be converted into the corresponding electrical values. So that values only we can able to process. So for that only we are using different type of sensors. So first sensors, after that there is a gateway. So some values we have collected that should be connected to the internet, or it should be connected to the other part of a network. So for that you can see that there is a different blocks it is showing. The first one, it is showing PC. PC is personal computer, nothing but normally we are using that computer. So after the top of that PC there is a one small box, black box. You can see that that's a switch. So switch in the sense like it is able to transfer data from between, in single network itself it can able to transfer data. So suppose I want to transfer data from one network to another network. Suppose I have a 2 server, then we should use a router or something. So router or gateway we have to use it. So here again we have used a one router. So router is act as a gateway. So what actually it is doing is the data, whatever the data which is sending by the personal computer 1, 2, 3, 4, whatever it is. So that data it will go to the switch, automatically it will come to the server. That server will connect with the another server. So each server is having IP address is different, 10.0 and 20.0. So automatically to connect two different server we need a router. A router also here it is acting as a gateway. In actual gateway, what actually it is doing is above router there is one more gateway is there. What actually it is doing is one type of network into another network. It is helps to connect a one network into another. Suppose I want to connect a one network from your college to suppose a KSCB. So there may be two different network, right? So in that way, what we are doing is actual gateway we are using. So whatever the data we are entering at the computer, that will go to the switcher may be there. Switch will be there. So after from there it will go to the server. From there it will go to the gateway. Through the gateway, that gateway which will help us to connect to different network. One network it is in the Mahagurutech, Mahaguru technology, and another network may be in the KSCB. So it will help to connect these two different networks. So that is a part of a gateway. The same time IoT gateway, it is having a lot of other advantage, like it will help for a more privacy. It is providing a more privacy and some analysis also we can able. So IoT gateway is somewhat different from the normal network gateway. So after that you can see that first sensor part, then gateway, then after that it is data is going to connect to the cloud. So all of us are having a doubt what is cloud. The cloud, you can see that cloud is nothing but it is like a normal data storage, nothing but it's like a CPU, a normal data storage. In that data storage, so this is a cloud place. Actually it is showing like a one circle, different circle. So there it is having a different platforms are there. Here we can store the data, we can analyze the data, or we can identify the data, we can remove some errors or bugs, we can able to reduce it, and so many applications are, we can predict the data. All these things we can able to do it at cloud's place. At the same time, the whatever the data it will be sensing from the sensor, first it will go to the gateway, then it will go to the cloud, so automatically it will store there. So how the data is storing, so that's a question. So always we will be having a two end, right? One source end and one destination end will be there, right? So one source end means suppose I have a one automobile sensor is there, that temperature sensor, that temperature sensor value always it is stored in the controller. So controller is the source. The whatever the controller is sitting inside the car, that is the source, and destination is my mobile app. Okay, so these two devices, these two machines will be having a common password key, authentication key always will be there. With this authentication key only it can able to transfer a data, or it is able to store the data. So what actually it is doing is, the sensor is sensing the data, and it will come as a electrical parameter come into the controller. It's a controller will be there, that controller will connect with the gateway, so gateway will go into the cloud. So to store that particular data, we should have an authentication key, or controller should have an authentication key. So always this controller, the suppose we are considering a car, the car controller sending a data with an authentication key. So when it is coming into the cloud part, first it will check whether the password is correct or not. Then only the storage space it will open. Automatically it will store the data. After that it will close it. It is like a locker type. So there is a locker. Let us we can consider there is a locker. The two keys there, two same keys there. One key it will give to the mobile phone. One key it will give to the car controller. So with that automatically it will come to the cloud place. It will open, store the data, or it can take the data. It's like a bidirectional. Okay, so cloud is nothing but like a storage space. So apart from the storage, we can able to do some analysis. We can do, we can prediction we can do, or we can store the data, or we can make it like a pending. All the work we can able to do it. Okay, so on the right top you can see that so many symbols. So these are the different firms actually they are providing a IoT cloud platform. Already it is available. Salesforce is one of the IoT cloud. They are providing IoT cloud. Amazon Web Services they are providing, and Bosch IoT is there, and ThingWorks and ThinkSpeak and Cisco IoT, IBM Watson, Microsoft Azure, SAP. So these are the different firms they are providing IoT cloud. And freely also they are providing some of them, like a ThingWorks and ThinkSpeak they are providing a free, and Salesforce also on some part we can use as a IBM Watson also like a trial version, like we can use as a free version, we can use it. So licensed version also is there. So what's the difference between licensed version and the free version? Means licensed version will be having a more secure part, but free version doesn't have a that much secure, because free version normally most of them are using like a for a trial run of a project. So after that, if you want to run a better project, like a long time project, and should not affect our data privacy, then we have to go for a licensed version. Okay, so if you are taking a licensed version, automatically that part, the privacy part will take care by the company. So whatever the IBM or Cisco, they will take care. So this is the cloud part. So this is actually the simple way. So sensor we have, gateway will be there. Gateway will helps to connect one network to another network. That is, sensor is having a one network, cloud is having another network. So it will connect two different network. So cloud, already we discussed what is cloud. This cloud, we can do analysis all these portions. After that, with the help of mobile app, it can able to connect with the cloud. So automatically we can take the data. So only one thing, both the section, the destination source should have an internet. If there is no internet, nothing is possible. Okay. This is a simple way how we are connecting. So like a green symbol, it is showing it is like a different devices that is connected to IoT gateway, and this may be different actuators connected to the cloud, and the end user may be actuator or any display devices. So now we are coming to the application of IoT. Okay. So now this is IoT application in the wearable technology. So now every the picture you can see that there's a sunglass is there. After that there is a ID card is there. That's a smart tracker. After a smart watch is there, a smartphone is there, and smart shoe is there. So every so whatever we are wearing in every part of that material is having a IoT component. A smart glass. So I think most of you have seen that recently the Geo has announced their new smart glass. So it is having its own projector. I think most of you has, otherwise you can go to the Google and you can they have a one good advertisement also is there about that particular product. Recently only they have launched in India. So I think 3 weeks before. So what is the thing is we can able to it is having a projector. With that projector we can able to see in front of our eye, we can able to see the big screen, and at the same time this smart glass, it is connected to the watch. So watch means it is connected, so whatever the notification it is coming automatically, that notification we can able to see at the in front of eye, we can able to access also. At the same time this smart glass we can use as a projector, so we can access the notification, we can read the materials, whatever the material it is coming into the mobile phone or watch, that we can able to easily view through the smart glass. So that is the thing actually. And at the smart tracker it is common. I think in most of the schools and colleges they are using a smart tracker for as an ID card. So it is having a GPS system. A GPS system, it is connected with the mobile phone. It can able to track easily wherever we are, where we are going. So where actually we are residing now. So all this data easily it can be tracked by the smart tracker. After smartwatch already we are explained, it is having a lot of functionalities. A smartphone also, a smart shoes. In the recently Nike has launched a smart shoes for a sports person. Like so one of the main problem for a sports person is always they want to, while practicing or doing a exercise, they want to check the health checkup is correct or not. Always they want to check whether the heartbeat is correct or is going wrong or not. So this smart shoes actually it is having a facility to having a sensor to check the pulses from the leg. It will take the pulses or heartbeat it will take, and it will create as a message into the mobile phone. So always we can able to see that. At the same time the sensor will collect the heart rate. If any abnormality, that will be reflected in our body also. Some vibration we will get it. That from that you have to identify your pressure rate is somewhat high or low. So from that you can easily identify that. At the same time there is a one more new technology it came. When exercising or playing, the shoe is losing. So one of the main problem in the playing part. So those who are playing, so always the shoe will come to the lose the shoes. So in smart shoes, what actually it is doing is automatically it is tighten the shoe. When it is losing, automatically it will tightens. So when they are doing rugby or like a basketball, it's very difficult to always tighten the shoes all the times, because they cannot able to concentrate at the game. So smart shoes that will help to automatically tighten the shoes. At the same time it will check the health monitor also. And one more one video will show that, and I don't know it is possible to hear the words. I think it can able to see the video. It's like a smart glass. Smart glass. What is a, so what actually it is this video is representing is smart, with the smart glass, how it we can able to use in a effectiveness industry. So that is the thing actually I am going to show now. I think the audio is not audible. So this whatever it is showing in black, it is viewing through the glass actually. So it's scanning through the smart glass. So all the practice it is. So this is it showed that this with the smart glass how it will helps in industry. So from the video we identified that like 4 hours work he has completed within 8 minutes, correct, and but efficiently there is no error actually, and whatever the data he is scanning through the smart glass it is logged also simultaneously it is logged in the system also. So it's very easy to transfer store the data and to do a work efficiently. Okay, so that's a smart glass in industry how it helps the now just we have seen the video. So now just I show that one advertisement of one shoe like how the smart shoe will work. So it's having a sensor, it will always it will check the health monitoring. Below that it is having a so you can see that so many sensors are there. With the sensors always it will store the it will store our health condition. Health condition it will store automatically. It is providing a lightning also, smart lightning also. So that is smart shoes, it works in IoT. And this is a different home automation devices like already you know that Echo Dot is all already it is very much used in all over the world. And after that there is different intensity type lights. After that there's a sprinkler with the help of the fourth one it is showing mobile app with the system, that is sprinkler. It will check the automatically, it will check the weather monitoring, and with that weather monitoring whether it is raining today, if it is raining or not, with that sprinkler it will switch on. If it is raining, the weathercast it is showing it is raining, the sprinkler that will not work. If it is too hot, automatically that will be sensed by the devices and sprinkler automatically to switch on. So what all the process we can able to see through the mobile app, or we can manually also we can do at the same time. This system is automatically it is connected to the weather monitoring system, and through that weather monitoring it can able to identify whether today is a rainy day or hot day. With that it can able to pump the water to the farm or like a to the garden. So next after that you can say there is a new system launched by the Samsung. I'll show that video. I don't know that we, then I think I cannot able to hear the. So automatically it is cleaning. So everything it is on the fridge. When we are operating the fridge, all the actions or in the house we can able to do it. We can switch on the vacuum cleaner, or we can switch on the AC. We can switch on the washing machine. This camera also it is connected to the refrigerator, so we can see. See, different windows are protected with the sensors that is connected to the refrigerator. So someone is open or something is happened, automatically that will be come to the refrigerator screen. at the same time, it is having a one more option like suppose we are going for a shopping and we don't know what are the items which is present in the fridge or in the fridge. So what actually it is doing is automatically it will list the component, whatever the component which is present in the fridge, and that it will send us a message to our phone. So with that we can able to purchase. We can do the purchase with that list. So that also is another option actually it is available. And the last one is the Wemo. It's a smart plug actually. That smart plug what actually it is doing is it is connecting with the app. The same time it is monitoring the how much current we have spent, and with that it is generating the bill also. If suppose if we are connected a mobile phone for 1 hour, so at the end automatically it will send a message. That message will be having a amount, how much amount actually how much amount of energy it has spent for that one hour. From that is calculating our energy bill also. So with that we can able to plan also. So it's like a this is like a smart plug. So when we are coming into the agriculture section, so we can see that there is a different drones are there, intelligent silos are there, satellites, mobile radio channels, and farm robots are there, analysis platform. So different things are there. So in drones and soil sensors, what actually it is doing is drones always it is checking the field maps and deliver area infrared photos, providing the information on the condition of the crops actually. And soil sensors always it is checking whether the soil content is having a nutrient content is there or not. All this data it will and it will send to the analysis or the control room will be there. It will send data to that control room. And that intelligent silos, you can see that. So what this is a different sensors, is a storage space actually. In that storage there is a different actually stock how much the component is at the storage space. With that he can able to move forward. Actually he's current amount. So you get a proper idea about what are how much the present at the storage space. With that he can move forward. At the same time different sensors and drones and everything is there. There's a weather monitoring through the satellite and all. Will get a weather monitoring also will be there. That information first it will come to the analysis platform. From that it can able to predict with the help of machine learning algorithm. We can able to predict. We can able to analysis the we can able to predict the future. At the same time we can able to analyze the data. So with that data we can able to move forward. So that will helps to increase the efficiency or reduce the wastage. Okay. So that is actually in agriculture sector. And next we are coming into the transportation section. So there's now I am going to show you one video like how the IoT can reduce the road accidents. So this video actually it is related to the one component luminance. So that's a component it is developed by China. So because most of the death actually in China, most of the death is happening due to the road accidents. To reduce that, they have created one IoT company. Pedestrian light system. So suppose one pedestrian is moving from one side to another, so automatically it will indicate. So that indication it will come inside the car dashboard. So from some long distance, some long distance, he can able to identify whether any pedestrian is going or not. From the 400 meter, showing from the 400 meter, he can able to identify whether any pedestrian is there or not. So that indication it will come to the dashboard of the car. automatically he can manage the control the speed. At the same time, you can see that there's a high beam light, so that automatically it will help the drivers to identify. So in this way, actually, in Bangalore also recently, some students, they have developed this intelligent transportation system. The same way. These are the different areas. So IoT is having a, not at all in home applications, it's having a application in different areas. It's applications, and it's having application home automation. It's having application in agriculture. It's having application in transportation, and it's having application in industry. So when we are coming to the industry, now it is industry 4.0 it is running. So industry 4.0, you can see that. So it is totally, it is related to cyber physical systems. That means it's cyber security and IoT and network. So in industry 3.0, you can see that automation, computers and electronics. But industry 4.0, from the picture we can see that we have all the systems connected with the electronics, like a home automatic devices. At the same time, it is connecting wirelessly, transferring a data from one device to another device through a wireless communication. So that is actually an IoT. IoT is having a major role in the industry. So in IoT in the industry, actually it's named as industrial IoT, IIoT, industrial Internet of Things. So it is having its own different areas, because when we are coming into the industrial part, that whatever the system or controllers or security protection or connection or communication, whatever the things it is coming into the industry part, it should be somewhat higher than the home application section, because it should be secure. First of all, when we are coming into the industry, it should be secure, and whatever the data it is analyzed by the device should be perfect, should have a good accuracy. Otherwise, what will happen? It will reduce the efficiency or reduce the efficiency of a total workage. That will increase the wastage of a product. So if wastage is increasing, means automatically the profit will come down, right? So when we are comparing the home application with the industrial application, the industrial application should have all the systems should be some more accurate. Or whatever the components, IoT components we are using in this section, it should be some more accurate, and it should provide a better result. So we know that all the technologies, whatever the technology in our world, it is having its own challenges and problems. Pain points are there always, right? So IoT is having one of the major problems. We know that. So even though all of them are telling 2030 our complete world is going to connect with IoT, at that time itself we have to think, if all the devices are connecting automatically, this all the data it is going to the cloud. So there is one question always it is arising, like is it we have that much cloud space is available? That's one question. Second question, if you are transferring all this data to the cloud, it should how to ensure that it is secure or not? Another one. And suppose if you want to connect all these devices to the cloud, we should have that much strong internet or that net facility communication facility we should have. So these are the major problems actually it is arising in the IoT sector. So with that, actually there is we know that now there is so many IoT routing protocol and data link layer protocol, so different protocols are actually it is running. So that has to be for when we are thinking related to a security related thing, automatically each protocol has to be reinvented in the sense like it has to be redesigned. The security aspect, at the same time data storage also it is going to increase. If data storage is increasing, automatically the jamming has happened. Jamming means the sense like now suppose if it is transferring a data 1 million or 1000 kbps data, suppose if it is sending, if 2030 if all the devices we are connecting, means it is going to 100 times greater, correct? So automatically all the data are transferring through this channel. So jamming should not have. Jamming in the sense like if all the data is simultaneously, if you transferring automatically, what will happen? It will come to the jamming section. So automatically, completely is like a, it is like a full traffic at a town. No one can able to move from one place to another place. Correct. So what's the so why this is happening means there is no proper communication path. So that's a problem. So before connecting all these devices to the cloud, we should have a proper communication path or communication channel. The same time, to control all these channels, we should have a good protocols also should be there. So that is one of the challenges now facing. There are lots of researchers actually it is going on now. So that will be cleared anyway. And as per the IOT's analysis by the Cisco Systems Private Limited, so what they are telling is 2020 38.3%. As per the new survey, almost 31% devices now it is connected with the IoT. Telling about like a industrial and like a home applications. So in industrial, most of them are going into the IoT section because increasing the which helps to increase the efficiency of a device, increase the profit, and time to time errors also it can able to identify. Time to time errors, if it's finding out means easily it can able to recover. If it is error is coming very large case means very difficult, that will affect hugely in the profit sector. So most of them are coming into the IoT, automatic automation, like all the factory with the IoT. Automatic, it has to sense all these things, and it has to with the help of robotics. Now all of them are doing in automatic factory actually. So when we are coming into the real thing, when we are coming into the real picture, suppose a student or anyone wants to do a project with IoT, how to do? So that's a question. So that's the main thing. As a beginner, they should know what are the different controllers actually we need to select. Suppose one student want to control one bulb with a mobile app, how to do? Or what are the different equipments or components it is needed? So that's the question. So that is I am going to answer now. So this is a basic architecture. This architecture, I think most of the students have your brain is fully filled with this different types of architectures, I think. So we know that all the architectures will be having a three sections will be there: one output section, one input section, and one controlling section. Correct. So here you know that sensors and input switches, keyboard, these all are input section, and different controllers like actuators, relays, switches, pulse width modulator, different sections are there. After that, output section is there like a notification display unit. At the heart of this all this system is like a controller. Correct. So I'm going to explain how to. Suppose I want to build a IoT. Suppose you want to build one IoT product. What are the components you need? Okay. So first the heart portion I am going to explain. So these are the normal, easily available controllers. As a student, suppose you want to do some projects in IoT, these are the best controllers now it is available. You can start with like a hobby project. You can start with these controllers. The first one, it is Node MCU ESP8266. It is also it is selling Arduino 8266. Its name is Arduino 8266. I think most of the students, they know about Arduino because in 10 years back 8051 it was common, or PIC it was common, but nowadays Arduino it is common for all the students. Like from the +2 itself they have started doing with the project with the help of an Arduino. But now, other than Arduino, this Node MCU ESP8266 is a very basic one. So what is the peculiarity? What is the difference from the Arduino is this Node MCU ESP8266, it is having its own Wi-Fi module. Like our mobile phone is having a mobile phone plus Wi-Fi module is there, no? Same way. This controller is having its own, like Arduino, it is having, it can able to take a different data and it can able to process. At the same time, it can able to process whatever the data which is processed, it can produce as an output or to the display device or to the actuators. So these are the normal processing which is happening with the help of Arduino. Node MCU also it is possible, plus this can able to in Node MCU ESP8266, it can able to connect with the internet. It's having its own Wi-Fi facilities there. Just we need like a mobile phone. What actually, suppose in mobile phone we need to connect with the Wi-Fi. What actually we are doing? We are taking a Wi-Fi connection. We are entering your username, password. Automatically, that if Wi-Fi connection is available, automatically our mobile phone will connect with the Wi-Fi. Same way, nothing else. Node MCU also same way. Here one username password, Wi-Fi username password. Just we can put it there automatically. This controller we can connect with the Wi-Fi. So one part is over. One problem is over. So one problem is in the sense like source section. Our question is how the source section, source in the sense like suppose I want to connect a bulb to the internet, how it is doing. So that is a question just now I answered. This bulb you are connecting with this controller, automatically whatever the data which is reading from the bulb, automatically that will be logged into the controller memory. This controller memory is having always already it is having a Wi-Fi facility. So with the help of this Wi-Fi controller, Wi-Fi chip, it will connect to the internet. So with the internet, we can able to log the status of our bulb. We can store into the cloud. So directly we can store it. Okay. So the one thing is solved. The same time we can able to use it as a normal 8051 or Arduino. It can able to easily we can use it. Another one is ESP32 development board. So it is having a one more facility. So first one it is having only a Wi-Fi facility. Next one it is having a Wi-Fi plus Bluetooth. Okay, so it is having its own Bluetooth facility, ESP32. So it's a same family actually ESP32. So it's a controller. Again, I am telling it is a controller. It is having a memory, RAM, ROM, all these things actually. So I am not going deeper into that. So you can easily available. It is in the net. You can search that data sheet. So it is having a Wi-Fi facility plus Bluetooth. So suppose if you want to connect a two device through a Bluetooth, that you can do with the ESP32. Okay. Next one, again Arduino recently they have developed Arduino Uno plus Wi-Fi. So this is having a, so what's the difference between Node MCU and Arduino Uno plus Wi-Fi is, so Arduino Node MCU ESP8266 or ESP32, it is having a less number of analog pins. We know that we have a mainly two type of signal actually we have. One is analog signal, another one is digital signal. Or we need to process a two type of signals. Analog signal also we need to process digital. So analog signal means you can see that in ECG unit, you can see that display always the one signal is continuously it is varying. So that type of signal we can call it as analog. So digital in the sense like it's only two state like 1 and 0s. So both type data we can able to process or we can able to analyze with the help of these controllers. But in the case of Node MCU ESP8266, there is only a one analog pin. Okay, but when we are coming into the third picture, third right one, like Uno plus Wi-Fi R3, it is having a 6 analog A0, A1, A2, A3, F4, F5. 6 analog pins are actually it is available. 6 analog pins actually it is available. So that's the difference. And compared to Node MCU, it is having a more space and more ground pin, and at the same time it is having a more digital pin compared to that. And if you are going into the deep, there is a PWM signals. We can feed a PWM signal into the controller that will be more into the Arduino Uno. So this is for so many other features also it is available. Okay, so that's the advantage of Uno plus Wi-Fi. So, but as a beginner, Node MCU ESP8266 is better to start. ESP32 also it is good one. And at the same time, when we are coming into the Arduino, its operating voltage is having a 2 operating voltage, like a 5 volt also is there, 3.3 volt also is there. But when we are coming into the Node MCU, it is having only a 3.3 volt only it is needed to operate. But here actually it is needed 5 volt. Okay, maximum 20 volt, till maximum 20 volt we can give. So if more than 20 volt, because here it is a regulator is there, that automatically if you are giving an adapter 20 volt adapter, if it is giving 20 volt, if it is giving, automatically there is a regulator, it will convert it into a 5 volt. Okay, so more than 20 volt if it is giving means that will spoil the device. Okay, but when we are coming to the Node MCU ESP8266, only 3.3 volt only it is required to operate. ESP32 also it is like that. But then it required a 5 volt. 5 volt it is required to operate. Okay, it is having an option of 3.3 volt. Some cases we can use it. Suppose if we need some sensors, suppose we are connecting some sensors, if you are connecting with a node, I'm sure that only this needed 3.3 volt that we can give from this Arduino. Okay, so these are the best 3 controllers that you can start your IoT first project with these 3 devices. It's easily available. It's having a cost like 300 to 500. It's easily available. Okay. So this is controller section. So after the controller section, I told some communication part is there, correct? Communication. So these are the different areas and different so what actually we have some network always will be there. So normal cases in previous, all these controllers are actually using Bluetooth and Wi-Fi, right? So many other things also is there. So I think you can see that picture on the y-axis it is showed the bandwidth, x-axis it is showed the how much distance it can able to transfer data with each technology. So RFID it can able to transfer data like 1 meter to 10 meter only it's possible, maximum 10 meter. And the Bluetooth and Zigbee you can see that 100 meter. Wi-Fi also 100 meter only will get that range. Okay, and Wi-Fi Hello is another IEEE standard one protocol. So that it is provide more than 100 meter, like 100 meter to some 500. They are telling like 500 meter it is able to send the data. And another thing you can see that LoRaWAN, narrowband IoT, LTE, long-term evolution for mobile communication, 3G, 4G, Sigfox also is a low power wide area network one technology. Okay, so these are the different technology actually normally using in some industrials, because it can able to transfer like a 10 kilometers in rural places. If it is using in a rural place also, this LoRaWAN, Sigfox, NB-IoT, like a low power wide area network communication, you can able to transfer data from 100 meter or from till 10 kilometers. In some journals they are telling is if it is a point-to-point communication, that means the LoRaWAN, two-side LoRaWAN, it is point-to-point directly. If it is there is no obstacles between these two destination and the source, this LoRaWAN can able to transfer data till 100 kilometers. They're telling like point to point. Point to point means should be contact each other. Some line of contact should be there. So that is, in that case, it can able to transfer a data for 100 kilometers. They're telling, I don't know, it's not, some journals they approved, but when we are coming in the real application, is it possible or not, that we have to check it. In most of the cases, we are using LTE. LTE, you can see that like with the help of SIM, we can able to connect all these things. And narrowband IoT also the same. Okay, just I will show that what are the different communication controllers. Suppose I want to use a Wi-Fi controller, Arduino. Suppose I want to use as a IoT. Arduino I want to use for IoT. How to connect? So we know that Arduino alone don't have any communication protocol. Like a Wi-Fi is not there, Bluetooth is nothing, is there, simple Arduino. But I want to connect. So there's a possibility is there. So there is a separate Wi-Fi controller is there. That Wi-Fi controller and Arduino we can able to connect. Then we can use for an IoT. So like different controllers are there. I'll show that. So these are the different communication devices. First one it is showed. I told suppose you want to connect an Arduino with a IoT. So what you have to do is first you have to interconnect this ESP8266 with the Arduino. So automatically this Arduino it is like a Arduino Uno plus Wi-Fi, that device. Same as like Arduino Uno plus Wi-Fi. So automatically it will work as a Wi-Fi controller. Arduino will work as a Wi-Fi controller. After that you can connect it with the IoT. So next one is Zigbee module. Zigbee module, most of the home applications we are actually using. So most of you know that what is Zigbee and all. So it is actually coming under IEEE 802.15.4. So that's a protocol worldwide. It is accepted by the this version, and it is an open global standard. It is low cost and low power. So now its operating frequency actually it is 2.4 gigahertz. It is there, 900 megahertz is there, 868, and some of this frequency it will work it. Okay, so normal home applications we can use it. Okay, now you can see that Zigbee it is working for 10 meter to 100 meter. Bluetooth also it is 10 meter to 100 meter. Wi-Fi also it is for 10 meter to 100 meter. So in that range you will get it. Next one, narrowband IoT. So narrowband IoT, this controller actually it is using for Raspberry Pi and all. So there's Edge, GPRS, and so these all are using for Raspberry Pi. So this narrowband IoT, you can see that it can able to connect a data, transfer data till 10 kilometers. Okay. So this is a controller that you can use it. Another one is in 4G LTE. I think this all of you know that. I think this normally we are using all the projects. So that also it can able to use it LTE SIM. So that also it can able to transfer data till 10 kilometers. So another one, the bottom one, it showed LoRa, long range detection. So long range wireless area network, that is LoRa technology. LoRa is one of the technology. It is developed by a Semtech. It's a US based company. So LoRa wide area network, there is a separate module is there. So this is one of the module, actually it can able to transfer data from already I explained till 10 kilometers. If it is same line of contact, automatically we can able to transfer 50 kilometers or 100 kilometers that early. And it's a low power device. It's very less power it will take.
And then more numbers started coming into the equation.
Hello. Okay. So long range we can able to communicate. Okay. Next, when we are taking a data with the help of these controllers, we are communicating with the help of these controllers, communication devices, and after that it comes to the cloud. What are the things actually it is doing? So in clouds, these are the process actually it is doing: data linkage, query management, it will generate a report, and catalog search it will do, data analysis will do, rule of execution. All these steps actually it is doing inside the cloud.
Mahaguru Institute of Technology. Good results, university ranks and excellent placements every year. Mahaguru Institute of Technology, Kayamkulam.